Hi, and welcome to episode 118 of the weekly Google Cloud Platform podcast. I'm Mark Mandel, and I'm here with my colleague, Melanie Warwick. Melanie, how are you doing today?
Hi, Mark. I'm here.
You're here.
That's the important part.
You are here. You're not in SF, but you've been a little under the weather, unfortunately.
I know. I have been a little under the weather.
But I'm glad to hear you're doing better.
Thank you.
So this week, we have a really great episode with Morgan McLean and JBD from OpenCensus coming to talk to us all about this open source project, which is super, super exciting.
Yes, definitely. As always, we like to kick off our podcast with cool things of the week and end with a question. And this week's question is, I heard there are abilities to natively extend Kubernetes. What does that mean? And also, how do I do that? And, as always, God only knows where that question might have come from.
Maybe me. It might have been from me.
Maybe you, but maybe not.
Maybe not.
So to kick off our cool things of the week, for Tensorflow, they're already at release 1.6, which is impressive considering I know they just released 1.5 not too long ago.
Nice.
They also have their Dev Summit coming up at the end of this month on March 30th, and we'll provide a link in the show notes. And our colleagues, Yufeng and Sarah, both came together and did a video recently. I know Yufeng's been doing a number of videos on AI, and they discussed how you can do TensorFlow object detection in iOS, and they basically build a custom object detection mobile app. And so we'll include a link to that video.
Awesome. Cool. So this week, I'm going to plug one of my own things, which is kind of cool and exciting. I've been working with Ubisoft and a bunch of Googlers as well, and a bunch of other Ubisoft employees to work on a open source dedicated game server hosting open source project. It's called Agones. I will put a link to the GitHub in the show notes as well as the blog post announcing it all. But it's an open source project for running dedicated game servers for like real-time multiplayer games at scale on top of Kubernetes. So some of you may have seen some of my blog posts talking about doing that kind of stuff. This is essentially a productization of that running as an open source project. So I'm pretty excited about it, and we want a lot of people to get involved. So if this sounds interesting to you, please come join us on the GitHub and the Google group and follow us on Twitter.
You've been working very hard on this. This is definitely a wonderful achievement.
I'm pretty excited.
You should be. I can't wait to hear when it's applied to something, like what the first game it gets applied to.
Yeah, we're doing stuff. But yeah, lots of details in the blog post for sure. Thirdly, we have a blog post by a fellow developer advocate, Colt McCandless. He has a bunch of really nice tips and tricks for optimizing performance on Google Cloud Storage, specifically around uploading and downloading files. He has a bunch of best practices for, say, like smaller files versus bigger files, different command line parameters you can try, all sorts of interesting tips and tricks. There's one I particularly like, which is avoiding the sequencing naming bottleneck. He talks actually about how the namings of your files can actually impact the performance of uploading files into Google Cloud Storage and why that actually is. So yeah, if you do a lot of stuff with Google Cloud Storage, you might want to check this out because it's particularly interesting to make sure you can get the biggest bang for your buck.
Definitely. And last but not least, we also want to mention that GCP has a new interactive CLI.
Yeah, this is super cool. I'm excited about this.
It actually really is. The blog post itself shows the CLI in action and gives you a visual understanding of what it looks like. Pretty neat because as you type, it does autocomplete. And then it's also showing definitions and information on a screen below. It's basically kind of halving the screen. And as you type, you can see what's going on below that. It reminds me a little bit of Jupyter Notebooks.
Nice. I haven't played with Jupyter Notebooks.
No, I was going to say, it's not exactly the same, but it's similar.
Interesting. No, and it's what I like about this is it works for gcloud, GSUtil, the BigQuery util, so BigQ, and kubectl. And yeah, I'm actually really excited to give this a shot. So gcloud alpha interactive is the command to start it. I don't really want to play with this. This looks really cool.
Yeah, I know. Agree with you. Anything that allows you to use the CLI more effectively makes me happy. All right. Well, Mark, I think it might be time for us to go talk with our guests.
Let's go do that then. Today, I'm very happy to have two people from the OpenCensus team joining us today. We have Morgan McLean. Did I get that right?
Yes, you did.
Excellent. Product manager for OpenCensus, as well as JBD, software engineer, joining us today. How are you both doing?
Great. How are you?
Doing well.
Good. Super happy to have you both here. I've been wanting to talk about OpenCensus for ages. Melanie can attest to that. But before we get stuck into that, I'd love to hear more about who you both are and what you do at Google. Morgan, why don't we start with you?
Sure. I've been at Google for about 2 years. I'm the product manager for tracing, debugging, and profiling. This includes some of our internal tools as well as those under the Stackdriver brand. One of the biggest things that I've been PMing in the last few years is OpenCensus, which is why I'm here to talk to you about it.
JBD?
I'm an engineer working on OpenCensus. I'm actually pretty new in this field, but I have quite significant background in building developer platforms and tools. In the recent years, I was actually focused on diagnostic tools of the Go programming language, and I kind of switched to this area. Maybe became too passionate too easily because, there are tons of potential and lots of gaps.
And you used to sit next to me, but now you don't anymore.
I'm sorry for that.
You've escaped.
Awesome. All right. So this seems like a good program manager question, which is always fun, but I'll be interested to hear the difference in response. At a high level, so what is OpenCensus? What is this project?
Yeah, so OpenCensus is a single distribution of language-specific libraries that pull data, so instrumentation and telemetry, out of your application so you can analyze the app's performance later on. So to start with, we're focusing on distributed traces and metrics. So to put that even more succinctly, OpenCensus gives you a really easy way to pull traces and metrics out of your app.
Who would be somebody that would use this?
Primarily developers of distributed services. So OpenCensus stems from a lot of our learnings at Google when we wanted to build distributed tracing, distributed metrics in a big way at high scale. But it really, the sort of benefits of OpenCensus are applicable to anybody building services with some amount of scale.
So you used two terms there, metrics, tracing.
Yes.
What are those things? What's metrics? What's tracing? What do those two words mean?
So I imagine a lot of listeners to the podcast are familiar with metrics. So, traditionally you'll pull things like CPU consumption or memory consumption out of any of the nodes that are hosting your application. And that's, a fairly well-solved problem. OpenCensus focuses on app-level metrics, so pulling out things like the number of requests made to your application or the latency of those requests, as well as any other metrics that you want to build into your code in a custom way, which is a little more difficult to pull out these days. The other term, distributed tracing, is probably one that people are less familiar with. So for those who don't know, a distributed trace lets you watch a single request as it propagates across all of your services. So for example, if you have an e-commerce application and a customer comes in and requests the cart service to add an item to their shopping cart, you might get calls to that shopping cart service that then propagate down to maybe a catalog service and others. And a single distributed trace shows you that entire chain of requests that was based off the single action made by the customer. And so it's really useful for a couple of reasons. First, to determine how your system operates, if you're not already familiar with it. And that's at a very basic level. But additionally, each hop along the way shows you the latency. And so when you want to reduce the latency of your application, which becomes really important as it grows, distributed tracing is a great way to do that. And finally, if you have an error during that request, the trace effectively works like a really long and powerful call stack, right? So you can actually see what happened that led to that error.
And my understanding is that OpenCensus is cloud agnostic. This is used for any kind of distributed system. Is that right?
Yeah, correct. We are not dependent on any cloud provider or metric collection or tracing backend. We collect data from your app or your services or frameworks in a vendor agnostic way, and then export them to specific backends so it can run anywhere and against any of the supported backends.
What sort of backends do you support?
Currently, the support is dependent on the language because lots of exporters are work in progress. For Go, we support Zipkin, Stackdriver, and Jaeger for tracing, Prometheus and Stackdriver monitoring for metric collection.
Can you also tell us a little more about the work that you do?
Yeah, I was actually about to add a little bit to the question of what do we do in terms of metric collection. As Morgan mentioned, that we are a general purpose library, so you can collect metrics on the measures you define. It could be related to your business cases, such as the number of transactions if you're a payment provider, or the number of videos you have processed if you are generating GIFs from videos. But on top of that, we have some canonical metrics for protocols such as HTTP and RPC frameworks, such as latency distribution or request or response size. And I think that's where OpenCensus is becoming more powerful because all these frameworks can expose these canonical metrics, and you just plug them to your exporter and get them out of the box without doing much.
That sounds also like a good reason why you would want to use something like OpenCensus rather than just pushing data straight to something like Stackdriver or Prometheus or something like that. It's giving you tools above and beyond what the backends you provide also give you.
They're, again, represented in the backend somehow, but it gives these frameworks to actually instrument without depending on any vendor, and it's very powerful. No framework can be opinionated enough to say that I'm just going to be, using the Prometheus instrumentation library, and this is the only exposition format I will support. Because, we widely depend on different backends, and that's where OpenCensus shines, because we're vendor agnostic.
Sweet. So JBD, you're probably a great person to ask for this. As a developer, if I'm sitting down and I'm like, I want to use OpenCensus with maybe an HTTP or I'm guessing gRPC, how does that look? What does that process look like?
Yeah, we currently support HTTP and gRPC both. And we usually expect users to start with our framework integrations. You pull the library and you pull the integration. Actually, for Java, gRPC Java is coming with OpenCensus integration out of the box. You don't have to do any additional thing in order to turn it on. And on top of that, you enable some exporters if you want to export the data to the backend. We expect users to start with these framework integrations, and on top of that, if they have any fine-grained measurements, depending on their technical requirements or their business cases, we expect them to, create custom traces or custom measures and collect more metrics. But we expect people to depend on the framework integrations. It gives organizations such an advantage to deploy this widely all across their stack very easily. And it's like one of the key things that we want to achieve. OpenCensus or any instrumentation layer is just, more useful if you can, deploy it all across the stack without much effort.
Nice. You mentioned Java and Go. Morgan, what languages is supported?
Yeah, so right now we have really good support across Java, Go, and C++ for both tracing and stats. And I believe we have tracing support for Ruby, Python, and PHP on top of that. Eventually, our goal, and we're already working towards this, is to get tracing and stat support across Java, Go, C++, .NET, Node.js, Ruby, Python, PHP, and I'm missing one. Yeah, no, which one am I missing?
Erlang, I think.
Erlang, that's still, I might still be missing another one, but yeah.
So since this is an open project, how can people contribute that are not necessarily at Google? Or how can people contribute in general?
It's very straightforward. You go to our GitHub organization, pick the language implementation you wanna. So we actually have two big we have language implementations, but on top of that, we also have a specs repo where we discuss the concepts and the overall design issues. If you want to contribute to the design issues and the concepts, you go to the specs repo, either start an issue or start a pull request if it's a trivial change that can be handled in the scope of a PR, and contribute it that way. If you want to contribute to the language implementations, you need to go to the language implementation repo. And again, we have contributing docs, so you just follow the steps and contribute.
Similar to most open source projects, basically.
Yeah, exactly. Yeah.
Nice. It also sounds like at Google, or at least coming out of Google in some other ways, we've got a lot of projects that seem to be doing related sort of things. I'm thinking like we were talking about gRPC just a little bit ago. Istio seems to come to mind as well. Is there overlap there? I mean, you said you support gRPC, but is there overlap from like gRPC or Istio with OpenCensus or like hooks or anything special going on there?
Yeah, it's kind of interesting because just to give you a bit of history, like OpenCensus is an open source version of something called Census, which is our instrumentation framework that we use inside of Google. And in many ways, gRPC and Envoy are equivalents of the systems that Census inside of Google hooks into. And so interestingly, with these other projects being open source at the same time, we have a big opportunity to integrate with them to give external developers the same experience that we have inside of Google for basically automatic tracing on all requests that propagate through our network. And so to answer your question a little more succinctly, then yes. So we've already built automatic integration for gRPC. We're building automatic integration for Envoy right now. And so Envoy, of course, is the application sidecar component of the Istio project. And then for the Istio mixer, which is another part of the Istio project, we have some designs that we'll start working on shortly for doing things like tracing aggregation. So you can capture traces and configure your backend a little more efficiently.
Morgan, you were talking a little bit about the history, but how did it go from being Census to OpenCensus?
Yeah, it's actually a really good question. We have a blog post coming out on this soon. So there were a couple of factors at play. For one, the Census team had simply been wanting to open source their work for quite some time. And Google has a long history of open sourcing projects, even when there's no sort of ulterior motive to doing it, just because teams inside are encouraged to do that and make things available to the community. Next, on Stackdriver Trace, we were developing our own instrumentation libraries, right? So this effort has, in the long run, is going to be replaced with OpenCensus. And the cost of developing these libraries, as any vendor in the industry can attest to, is rather high. And on top of that, the cost of maintaining these libraries, because you have to have these integrations into various web frameworks across so many languages, just continues to be high. And so you have these very large teams who are just ensuring that your tracing system can work with, framework X on language Y. And so we were hoping to find a more creative solution to addressing that, both for us and our competitors. And then finally at Google, there was a need, particularly on the storage teams, to get more instrumentation into cloud client libraries. So particularly services like Bigtable and Spanner. Customers do sometimes have performance challenges, and we need a quicker way of determining if that's due to something happening on the customer's end. Maybe they're calling an API in a way that we don't really recommend, a way it's not designed for, or maybe there's legitimately a problem on the service. And those teams in the past have lacked a lot of insight into that. And so resolving some customer performance issues would take days, right? Or even just more hours than they would want. And so getting a way for them to get both trace requests going through from their client libraries to our services, and also just ensure that they can give us some more instrumentation to customers regardless of whatever tracing or metrics backend that they're using. So not just Stackdriver. And so really the decision to release and so heavily fund the OpenCensus project was due to a culmination of these factors, right? And it was sort of this perfect storm of wanting to open source things, that our own tracing product needed better instrumentation, and then teams at Google wanted their customers to gain much more insight into their client libraries. And it worked out really well.
I could definitely see the value of having that holistic picture and being able to sort of remove from being specifically affiliated to a certain product or service, because that way you can drive after that holistic tracing.
Yeah, it would be, it'd be a much more challenging conversation with our partners in particular if we just went to them and were like, yeah, this is the libraries we created for our own, Stackdriver tracing product. You should use them too, right? Like a lot of partners wouldn't take that seriously for very good reasons, right? And they'd be somewhat suspicious of it. But it's interesting, when we meet with other vendors, particularly other vendors in this space who are also cloud vendors, like ourselves, or at least own large, well-used APIs. They have the exact same challenges. And so it becomes a very straightforward conversation, because we say, hey, you can embed this into your client libraries as well. And it turns out, I suspect, I don't know this for certain, but I suspect that the other cloud vendors, they also want this to work when people are using, third-party tracing applications, not just their own. And so the fact that this is an open project and is going to be gaining a lot more partners in the future is very appealing.
As a maintainer of some of these client libraries, we finally realized that, there's no point of having no vendor agnostic solution. And I think within the Go programming language scope, we were actually thinking about maybe we should have some tracing and some sort of like instrumentation library, not just tracing, but metrics in the standard library. But it became quite a clear case that this is not just like one language. Any organization you go, they depend on 3 or 4 languages. So you need to be able to, provide this all across different languages. And then I saw the actual clear benefit of OpenCensus and just decided to, join this project rather than, doing things in my own corner.
Yeah, so it sounds actually like the whole vision of it sounds amazing, in that in theory, if I set this up in OpenCensus inside my application, I could have metrics and tracing that goes all the way through from my custom application code all the way through to the SDKs that I use that integrate with the cloud that I'm on.
Yep.
And then potentially other clouds or other places around, assuming they also...
Yeah, or other APIs that you're calling, yeah.
That sounds kind of awesome.
Yeah, it really does.
And there's also an additional wire format standardization effort. So lots of vendors want to also standardize how we propagate the trace IDs around. So if a trace, for example, has been started in, somewhere in AWS X-Ray, we will be able to understand it and keep adding more to that trace and so on. So there's a big effort all across the other vendors to finally, create this agnostic view so we can actually gather, the instrumentation data and utilize it.
What additional feature enhancements or connections are you working on?
Yeah, we've got a couple things when we look sort of longer term, sort of through the end of 2018 for OpenCensus. One is something that we've called, it's got several different names, but it's, sort of retroactive tracing or delayed sampling. So, but effectively, it's making a decision on whether you want to trace a request, not at the beginning, so not when the request comes in and hits your load balancer, your very first service, but later on. And what this would enable is selectively sampling requests that have errors, for example, or requests that have higher latency. This is not a trivial thing to achieve, but we think we can do it, and we want to add it to OpenCensus for all vendors to take advantage of. If I look more at sort of the breadth for OpenCensus, there's a couple of sort of big rocks that we want to focus on. The biggest would be errors and logs. And so we haven't put a ton of thought into this yet, but one of the biggest advantages that we see of our telemetry systems internally inside of Google is being able to link traces to logs or traces to other signals. Basically being able to take the context of a request where something happened and include that on any other signals associated with that request. And we've also seen that being very effective with Stack Driver Trace with our customers on Google App Engine who get this built in. And it's sort of annoyingly hard to pull this off today with when you have like separate tracing and logging and error reporting and profiling in other libraries, right? Because most of them don't look for each other. You might be using libraries from different vendors. But if we bring this in through OpenCensus, then it actually starts gaining traction and achieves some amount of popularity. Everyone can benefit, even vendors who only offer a single feature like maybe logging, right? Or only tracing, can benefit from that correlation of signals, and their customers can benefit from being able to go from a trace that might be in Zipkin and tie that into some metrics that are in Prometheus or logs stored somewhere else. And that's really like one of the big things that we want to drive long term with OpenCensus is that correlation between signals.
That was going to lead into a question I was thinking about as you were saying it, which was you do both tracing and metrics. Like, Why do you put those two things together?
Part of it's just that those are sort of two areas in the market where we saw a need for some amount of, perhaps standardization is the wrong word, but some amount of convergence where, the market hadn't, for a long time hadn't been that well served by projects that did that. But additionally, it's that our visions are much grander, right? Like tracing and metrics is just the start. We eventually want to bring in logs, errors, profiling software, any other signals that we can bring in.
I want to say that OpenCensus is a cross-stack instrumentation framework. What we mean by cross-stack is we actually propagate some dimensions. We call them tags. So you can have, multiple different perspectives to take a look at your instrumentation data. These tags are arbitrary things. For example, you can ask questions like, give me all these metrics originated at this particular service, or give me all the metrics that has been originated by this specific customer. So the goal is actually have the tag propagation in place, and then multiple other signal types can benefit from that.
Have you had like a really good response from the community?
I think people are generally extremely interested because the gap is very clear. For most frameworks and library authors, there's absolutely no way to instrument. And they can clearly see that, this project is filling that gap. So the response has been very positive because we are addressing that.
Nice. Good to have the positive response already. And you said it was very new, so it was in the last month, right, that this was actually announced?
Yeah, we announced it, I think, last month. It's been almost a month or a couple of weeks.
Yeah, it was a fairly quiet announcement on the Google open source blog. We're having basically like a rolling launch.
Yes.
We're making more and more noise. We're going to more and more conferences, and we're making blog posts and just sort of trying to ramp up the level of attention that the project gets.
And JBD, you did a talk at KubeCon, didn't you?
We did actually. We did it together. That was the first talk we gave about this project, and I followed up with other talks. I think there's a lot of work in order to explain the concepts we have, why we solve the things the way we do, before giving them maybe the solution. So we're thinking about also spending some time, educating about these concepts. And our library implementations are still kind of like work in progress, and we sometimes break APIs, so we want to be in a very stable situation before we start, widely talking about this project and recommending it for the, general use.
Great. Is there anything else that you would want to plug around actual talks or other efforts or community involvement that's coming up?
We have a bunch of talks coming up. Morgan has a VelocityConf talk in June.
Yeah, I think we've got Velocity. We've also made applications for, and of course we haven't heard back yet, but I'm pretty confident we'll get into most of these. At KubeCon, SRECon, Monitorama, and then additionally some of the Google-specific conferences like GCP Next and Google I/O.
Basically wherever good presentations are found.
We're trying to cast a wide net. I'm sure there are conferences that we should be at, but maybe haven't applied to. But we're trying to go to as many as we feasibly can.
Wonderful. And if people are keen to either get involved or start playing with OpenCensus, where should they go?
They should go on opencensus.io and, take a look at our GitHub organization. I will put the links to your doc. So, check out our specs and language implementations and, give it a try. We have enough guidelines about getting started and can just try to use it and give us feedback. That will be very appreciated at this stage.
And I'm seeing here as well, there's a 2018 Google of Summer of Code.
That is also true. We have several ideas. So if you're interested, take a look at the list. Contact us.
Should they also send you examples of how they're using it and things that they're finding with it?
Oh, yeah, that would be awesome. We actually seen a bunch of, blog posts already from, several users. So it would be totally so nice if you can write any guidelines or, any tips. If you can write conceptual documentation, that would be also nice. I'm also trying to spend some time this week just to, write more documentation for the website. We will have, soon more, conceptual docs and so on. But, any help would be, highly appreciated.
Great. Well, we really appreciate you both taking your time to come and talk to us and share what OpenCensus is. Is there anything that you still wanted to mention before we close this out?
Not on my end.
Contributors?
Contribute.
Please contribute.
Please contribute. All right. Well, thank you again. And thank you, Mark, for getting this together for us.
Thank you so much for joining us. We really appreciate you taking the time.
Yeah, thanks for having us.
Thank you so much.
Thank you again, Morgan and JBD. It was great to talk to you about OpenCensus. It's always great to hear about what kind of open source projects are going on and how they're being supported. So, Mark, I think now it's time to ask you the question of the week. I heard that there are abilities to natively extend Kubernetes. What does that mean? And also, how do I do that?
Cool. So, I can now talk more openly about Gonads and the work I've been doing in that space. I have a whole bunch of questions of the week around Kubernetes, which are really nice.
It's very helpful.
Yeah, I want to give the short answer here, but I'm going to put a lot of resources in the show notes because there's a bunch of stuff around, and some of this can be a little bit hard to find. But it's something I want to talk about. So what does it mean to natively extend Kubernetes? Essentially, this means that Kubernetes has the ability to essentially add endpoints to the underlying API, which then propagates out. So if you want to add your own nouns to Kubernetes, for example, so you know how we have deployments and pods and things like that, Kubernetes has these things called custom resource definitions, which you can configure and install through YAML files of the API to add your own nouns. So if you want to add an Acme or a foo or a widget or whatever that thing is that you can then store configuration information against, you can do that inside Kubernetes. And I'm going to add some more links, but you can do that through custom resource definitions. And the second part is a set of things what probably either heard of either controllers or operators. I tend to use the term controllers just because that's the one I prefer. But those are the things that are custom pieces of code you can put inside Kubernetes to react to when custom resource definitions or other things, really anything, happens inside Kubernetes. So you may have seen there's like a memcached operator. I've seen Redis operators. I've seen a bunch of different ones around there. Gonads itself has custom resource definitions for game servers and a controller for that. But that combination combined means that suddenly you can install this stuff into Kubernetes. I can then go kubectl, get game server, for example, with the Gonads, and it shows up in natively inside Kubernetes. I even get code completion too, which is cool. If I look at the API points, I can see that extra stuff has been added. All that stuff is native inside Kubernetes. Like you can take advantage of security. It's all really, really cool stuff I'm really excited about. But with those two things, those are the two keywords that you're looking for there. But I'm going to put a bunch of stuff in the show notes with some video resources, links to articles, all the different Go libraries that usually you can use for all this kind of stuff too. So if this is stuff that you're interested in, you'll have a nice little resource there.
Great. Well, I think that about does it for this week. Mark, is there anywhere where people are going to be able to find you in the near future?
Absolutely. So I can talk now about all the things I'm doing at GDC because Gonads is out, which is lovely.
Yay!
So at GDC, I'll be at the booth. I'm doing a half-hour talk at the booth. We'll put links to where that is and when that is in the show notes. It's on Wednesday. I can't remember the exact time, unfortunately. I'll be talking at the booth about Gonads. We'll be doing a sponsored talk as well. Same thing, we'll be doing a What's New in Firebase and Google Cloud. So I'll be talking about that. We're also sponsoring the Women in Games International Party, so I'll just be there hanging out. We're doing Meet the Expert sessions. I think that's probably about it. But I'll be all around GDC. If anyone wants to find me, just hit me up on Twitter or email or LinkedIn.
And that's all next week?
That's all next week, yes.
Are you so excited?
Yes. Part of me is really, I love GDC. Part of me is very excited for it because there's so much going on. Part of me is almost really happy for it to be over.
Well, we'll talk about what you're going to do to relax once you're done, but I'm glad your big week is ahead of you.
Yeah. Are you going anywhere, doing anything?
No, I'm going to rest.
Excellent. Take care of yourself.
I will. All right. Well, I think that does it for us for this week.
Yeah, Melanie, thank you for joining me for yet another episode of the podcast.
Thank you.
And thanks to everyone for listening, and we'll see you all next week.